All right, welcome once again. This is the lecture number 2 of Artificial Intelligence course. In this session, we are going to talk about the intelligent agents. So essentially, we know this particular part, that in the pursuit of computers doing things which at moment people do better. For example, when I speak something, you are listening this, and when I ask the question, you can respond in the right way. So all these things, we believe that people do better. But I want this thing to be done by the computers. Understanding is this, that there is some environment, and in this environment, your agent actually have to operate. Okay, he have to operate something, do something. For example, if environment could be that there is some natural calamity happened, and there is a drone that is an agent. He flies and try to find out if there is someone stuck at some place. We must understand that agent is going to operate in this environment, but agent is not the part of this environment. It isn't actually outside this environment. So agent and environment are two entities. First, we have to understand this particular part. Agree? Do you agree with that? Yes?
Yeah, yes, sir.
Yeah.
Yeah.
So agent is actually outside. Okay. So if he is outside, so you have to understand that what is the state of the environment, what it looks like, how he understand. He needs some kind of sensors. For that, he needs some kind of sensors. The sensor could be anything. For example, he could have a camera. Sensor may be camera, temperature sensor. He may have a mic by which he can record that what the voice over there. Or so many things we can discuss based on the requirements. He may have radar or whatever equipment he has. So he has some sensors. By these sensors, he's deploy those sensors into the environment. And by this, he is going to get something. What he is going to get? He is going to get percept. We are going to call it percept. Okay, percept is again a technical word. So he is going to get the percept. And by this, after getting this percept, he have to do something in the environment, because he is here to do some kind of task. So how can he do that? So definitely he have to do some kind of processing. After getting this percept, he have to do some kind of processing. And after this processing, he understand that, okay, it looks like that I have to send this message, or I have to do a fire, for example, if it is a, he have to drop the packet which he has brought to that particular natural calamity positions. So he have some actuators. Actuators could be, for example, drop packet. Drop. There is something which actually drops that. Okay? By actuator, he sent the message that whatever is in your place, you can just drop that to the particular person, or communication device, for example, mobile, etc. So he is actually actuating that particular part, and by this actually goes inside. And by this, what happens, that earlier the state of the environment was even, now the state of environment becomes E2. Let's assume that there is an environment, and in this is, let's say, assume that there is some natural calamity has happened. And now this is our agent, and agent is, let's assume that a UAV that is flying over there and try to find out is there anyone. So what could be the actuators? What actuator?
A drone could be a drone could be an actuator.
Drone is the agent. Okay. Drone is
Sir, calling the rescue service. Calling the rescue service.
Calling the rescue service. Okay. And dropping the packet.
Alarm. Raising the alarm.
Raising a, yes. Maybe he can from there he can start a hooter. Okay. Whistle. Okay. Yeah. So all these things are actually actuator. You understand that what is actuator. So at that particular place, he going to do something. By this, yeah, he is going to perform something.
Sir, can we call it a trigger?
Yeah, trigger is a mechanism by which actually, Trigger is a mechanism by which this actuators actually get started.
I
So
think it's an
actuator
action,
are
right? It's an action.
Yeah.
Taken.
No. By actuator, action happens.
Yeah.
Okay? So
Through
this
actuators
is
action.
yeah. So it is a device because you can think that it is a device. Actuators are actually devices which actually enables that this would happen. So actuator. These are the devices. When we switch on these devices, they actually do something, right? Our understanding is this, that our agent is actually a rational agent. What do I mean by this? Again, it's a very important concept that we have touched in the last class also. So a rational agent means what? So let me take another example. Let's assume that there is a place A and there is a place B on the map, and you want to go from A to B. So you may have switched on your Google Map and ask that I want to go from A to B. Can you tell me the path? He can tell that one is this path, another is this path, another is this path. He can tell three paths to you. And it says that it is going to be 20 minutes. It's going to be 12 minutes. It is going to be 16 minutes. Definitely. What is the rationality? Which path you are going to select?
The shortest path, obviously.
The shortest path. You are going to select this particular path. By the rationality, you understand that this is the best path I am going to have. But let's assume that you have some more information. For example, if you open your window and you see that it is raining outside. What does it mean? It means that in this path there is a lake. In this path there is a underpath. I'm sorry. I think I should put it. I have put it different. Okay. So you understood that on this path there is a underpass. So you expect that it could be that there could be a water logging into this particular place when you reach at this particular location. Now, which is the best path?
The 16 minutes one.
16 one. 12 one is not now a good path. So this is an important thing, that if both the information is available to you, that what are the different paths plus what is the environmental or the current rainy situation, both information is given to you, you would be selecting the 12 one. But if this information is not available, weather information is not available, then you would be selecting. By this, you will be selecting 16 one. If weather information is not available, then you would be selecting the 12 one. So, which is the correct, most correct thing? Is actually the most correct answer when I was at the starting point when I was asking that I had to go from A to B, the most correct answer was 16. Okay, because it's the perfect answer. This is the correct answer. This is the right thing to do. But you don't know that what is going to happen. Let's assume that let me frame this question in a different way. Instead of 12 minutes, I say that 120 hours. Let's assume that you are moving from very far distant place, and in between also the weather can change. Okay, it can also be possible. So let's assume that I just increase 10 over there. So now when you started from here, when you started from your initial point, so which path you are going to take? Because at some later point of time the weather is going to be bad, so you right now you cannot do anything in this, okay, because you don't have the complete information. Definitely you have to go into this particular way, and definitely you are going to be stuck in that particular way because all the things are not given to you. Why you are going to take this particular path? Because all the things are not given to you. What would happen at later point of time is not available right now. So rational, this behavior that I'm going to take is a rational behavior. This we must understand. In many of the cases when we actually discuss any problem with the person, we actually are actually into that particular situation that he thinks based on his situation, he had decided that I should do this. But when he have done that, and when he have reached to this particular position, at that time, if somebody is going to evaluate that what is the situation, you must have come into this particular way. So this is actually wrong. Am I right or not? When the person reaches here, somebody instead of 120, he has spent 200 hours, let's assume that, and somebody is going to teach him that, okay, you must have taken this particular path. Is it right or wrong?
Yeah, I think it depends on the situation, sir, as you said.
Yeah. So what I'm telling that when the person started, situation was this, that map was telling 120 hour, 160 hour, 200 hour. So he have taken this particular path. What I'm going to tell that when the person had reached over here, at that time somebody started telling that, okay, since you instead of 120, you have spent 200 hours by coming to this particular way, you must have come from this way. Is it a right thing to tell?
No, sir, because it's a reactive approach, probably.
Yeah. So this I wanted to tell to you. Most of the time in our look, this course is actually philosophical course. It also teaches you something that when something happened at that time, if you are analyzing the thing, this kind of mistake we can do, because all these things were not available to him. So he, whatever he had taken, whether it was rational or not, we have to think in this particular way that whether at the initial point he was rational or not. All right. So this is a very important thing that the person should be. What is the rationality? Again, it comes into a different way to you. What is the rationality?
So that means that action was, sorry, sir, sorry for interrupting. That means
No,
that action was taken based on the information available at that point of time.
Correct. Yes. This is precisely you are telling exactly the same thing. Yeah.
And it can be wrong also, sir, right?
It can be wrong also. I think I missed this particular point. It can be wrong when it is wrong. When you reach over here, at that time it is wrong.
Yeah, means
At
if
the
consider.
final, if
Mhm.
we analyze, it could be wrong. Yeah. But tell me.
Yeah. No, yeah, just wanted to give an example, right? It says that there might be rain, but it actually doesn't rain in that path. Or
Yeah.
there was
Yeah.
traffic expected, but there was no traffic on that path.
This can also be possible. Okay.
Yeah.
So if traffic expected information is available over here, if let's assume that traffic expected information is available here, so this thing is going to be framed based on that. And if there is no rain, so definitely there is no rain, there is no traffic. So definitely things will change in between. But this reagent has not taken the wrong thing. At the end, if you analyze, looks like that he have failed because of these reasons, but actually it has not failed. We have to understand this. A failing system, a difficult system that actually have errors may be correct because he at that time he have taken the correct decision. Right now you can tell that, okay, this was a wrong. Make sense? All right. So this is very important to understand that what is the rationality. Next thing that we wanted to understand is
Yes, Professor, just one quick question. Based on the outcome, agent is not supposed to learn for the next time the decision needs to be taken?
based on right now. So look, the only issue that we had right now, that information was not available. Okay. If that information was available over here, whatever information you are going to tell, then I have taken it, and then the agent has taken a different decision. So how can we solve this particular problem that this information is not available? There is no way. Am I right? Am I making sense?
Yeah, I mean that I mean the one scenario could be that information was I mean might be available, but right approach was not taken by the agent.
This we cannot this we cannot talk about. So yes, this is not going to happen. This we don't expect. That information was available and system was telling that this is the shortest path, and my system is not taking the shortest path. We are not into that particular thing. Okay. What we are expecting that if the information is provided, my system is definitely going to take the right thing. Okay.
Okay, thank you.
The system is on the system side, we think that it is going to be correct. Okay. Setting we are going to talk, we are actually talking about. It is rational, then definitely it is going to take that particular decision. All right. Okay. There is an interesting thing that I wanted to tell you that how well how well the agent can behave. Now here, well is an important word. Okay, how can you define the word? Well, very challenging. Okay, right now we are not talking about it. We'll talk about this later. How well the agent can behave. Okay, it depends upon the nature of the environment. So what I wanted to tell that let's assume that you have developed an agent. Okay, maybe maybe a flying UAV that can blow whistles if we find out somebody into the uh, into into the natural calamity. Okay, he is going to he's a search agent. So this can it's how well means its performance depends upon the environment also, how that particular environment is. Do you agree with this?
Yeah.
So you actually what you think that there is an environment, and in this environment, this agent is going to work. So different environment could be there, na? For example, if it is an autonomous driving car, so autonomous driving car I can implement to go into, for example, Rajasthan, and I ask him to drive in Mumbai. I ask him to drive on hilly areas. All these things are different. Okay, but my hilly area, let's assume that hilly area, Rajasthan, where the roads are nearly there is no traffic on that. Mumbai, where a lot of traffic is there. So this same thing have different may have the different performance in the different environments. Does it make sense?
Yes, sir. I think that is where the learning and experience comes in, I think, sir. Correct? Hello?
Yeah. Actually, learning is done. Let's assume that learning is done. Okay. Let's assume the learning is part is done. So by learning, we have made it. If we had trained it in a different way, this agent would be a different agent. Okay. Based on our training, my agent is going to be different, going to differ. So right now, whatever training I have done, I have an agent. Makes sense? I have an agent. And now I wanted to find out that how good this particular agent is. If I change the environment, its performance is going to change. Does it make any sense? Yes,
I
sir.
think it
Correct,
again
sir.
Yes, yes,
that
yes.
in which environment it was trained, right? Right, sir?
Let me also tell that it can operate in any environment. Okay, it has trained in such a way so that it can operate in all the environment. Okay, then also the performance would be different. So when I say this particular thing, our understanding is that I may have different agents. Okay, A2, A3, A2, A3, different A4, different kind of environment I have. Yeah, sorry, agents I have. So if I apply those agents, let's assume that I'm going to conduct a race out of it's a autonomous vehicle. I'm going to conduct a race. So if it is going to be into A1, A2, A3, A4, so maybe A2 is going to win, then A3, then A1, then A4. But in a different environment, maybe A4 is winner, then A3, then A1, then A2. In the different environment, maybe different could be winner. It could be possible. Okay, for example, I just want to give another example. Somebody is a good software engineer. He want to work into different countries. So don't take my words, but if somebody works in country A, for example, India, for example, China, for example, US, so maybe in different environments, his performance could be different. Yes or no? This example may be difficult to understand, but because of you just see that because of the facilities that you get over there, because of the people, the way interact with you into that particular environment, you could be more productive in a different environment. Yes or no?
Yes, sir.
So,
Yes.
so essentially what happens that some environments are more difficult than others. Some environments are more difficult than that. So when we actually want to understand that how well, this is a very important thing here. Well is actually a loose term written over here, but it is actually trying to capture this essence that what is the performance. So performance depends upon environment also. So what generally our understanding is that performance is actually dependent that how well I have trained this particular system. But now what I'm telling that it is not only dependent upon this particular system, but also where it has been, it is going to be deployed. Environment is also going to be very important part. All right. Okay. So essentially, this last line is actually very simple. That actually says that agent choice of action actually what agent does. So agent actually sees that there is an environment state one. At this environment state, there is some percept. Percept is coming to me because he's going to understand that something is coming to him. So after seeing this, actually he perform, there is some function actually tells him that in this particular situation what action I should take. I think we need this particular function, and after that it actually goes, the environment goes to the another state. Again he senses that and then performs some actions. Environment changes to E3, and by this environment changes from one state to another. At the end what we want the environment should be some final state that actually we have decided on. So he want to do that. For example, if there is some, it's a natural calamity rescue operation, so he wanted to go into that situation that no human is inside that particular area and everybody has been rescued. So this is a very simple thing that at the end, in the environment, no person is there. Similarly, you can think on the other things also. Okay. All right. So we have seen that based on the environment, somebody is going to take the action. Based on environment, my agent is going to take the action. So how can I make it intelligent? Right now, my question is, yeah.
By training it in different environments?
By training is. So training is actually, again, you can say training is a, can you explain more on the training? What happens in training? So anybody can say training. So what do I mean by training?
Different parameters, sir. Different parameters, different conditions.
Different parameter tuning. So we tune that in this particular way that it is going to perform better. Yes.
Yeah, initially we'll assume some parameters, but as the experience grows, then probably based on the new parameters, you will add the parameters.
All right. So based on the things that actually we have discussed just now, let me just reframe it. Okay. So what I was doing that there was an environment state one, then it goes to the environment state two dot 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 dot. Then it goes to environment state final. That no person is just focus on the rescue situations. So this way we have reached to this particular place. Okay. And there could be that instead of this, I reach to some other state, say state number 5, then some new state. There is some states, and by this I reach over here. There could be another possibility also. So there are different way of going from here to here. Different actions I'm going to take by I'm reaching from here to here. So all these things are correct. All these methods are correct. But you will be definitely, if you evaluate, you would be telling that looks like that this particular way is actually efficient. Then it comes into the picture that looks like that this is an efficient way. Yes or no? This is looks like that this is efficient way, and that's why I tell that if somebody does into this particular way, he is an intelligent person. Okay, he is an intelligent person because he has optimized something. What he has optimized, the time, and he have done the thing in the fast way. So multiple ways would be there to solve particular problem, but one way that actually optimizes on some of the things that we would again discuss that what is that particular something. Right now it is a time only. So based on that we can tell that how good this particular thing is going to be. Yeah. To make the intelligence, we have to see that is there multiple choices, and out of those choices, how to select the best one. All right, what do I mean by this? So, once again, this is another technical representation that actually is not very difficult that we are actually right now currently talking about. So we were talking about that there is some environment. In this environment, my agent, this is a big entity that actually wanted to talk, operate. So what he does, he has some sensors. Sensor is inside this agent. Okay, we have temperature sensor, whatever he has. So he deploys those sensors, and by this he senses that what is there inside the environment, and what comes to him is a percent. What comes to him is a percent. We call it that as a percent. And after getting this percent, he does something. He does something. He try to understand that what action I should take, because he have to drive this particular environment in such a way so that a final state can be reached. So he tried to do some kind of computations and understand that looks like that I have to do this particular action. To perform that particular action, he have to initiate some of the actuators. So these are the devices which are actually initiated so that this action is performed on the environment. Perfect. So now let us try to understand what is inside this particular question mark box. This is the intelligence. Yes or no? This is what the intelligence is. Okay. So, I was asking you that how can we make the intelligent agent? So let's tone down this question to say how to make the intelligent. How to make the agent. So the question, the things would be that if you know that what are all possible environment ways. So let's assume that environment could be into the setting 1, environment 1, environment state 2, environment state 3, environment state 5. Let's assume that these are the 5 environmental states that we have. Environment could be in these 5 states. And what could be the percept? Percept could be A, B, C. Let's assume the 3 kind of percepts are there. Okay. So, so I think we should take an example so it would be more clear to you. So let's assume that you are running a factory where there is some some boiler that is there. Okay, boiler, you know that there is some heating thing. You want to maintain the temperature of that particular thing. So, so what could be the sensor if you want to maintain the temperature? What could be the sensor? Thermometer. The sensor is a thermometer. So I have a sensor that is a thermometer. So what is the percept? Percept is the reading that is going to come. So it could be that temperature is less than 50 degree, temperature is less than 100 degree, temperature is less than means less than 100 means between 50 and 100, and 150 temperature is actually less than 200, our temperature is greater than 200. Okay, let's assume that these are the different states that we can think based on the percept. So thermometer is going to give you a reading, and then percept is going to be that how I perceive it. I perceive it in this particular way. The temperature is less than 50, less than 100, something like that. So these are the 5 percepts I can get. Am I making sense?
Yes, sir.
Yes, yes, sir.
So I can say that this percept is A, this percept is B, this percept is C, this percept is D, this percept is E. That's a assume I said A, B, C, D, E. So what are the environmental situations? Now, what could be the environment? Environment, let me also write the environment. Environment 1 is cold when nothing is working. Environment 2 is actually a medium working environment. Environment 3 is good working environment. Environment 4 is actually hot environment. Environment 5 is some error state. Okay. So, all right. So what I have to do, let's assume that it is an even state. let me write state and percent. So in the even state, if I get A, B, C, D, E, all these percent are possible? Yes or no?
Yes, sir.
Maybe, may not be. Okay, if it is a cold state, how can be the temperature is greater than 200? Okay, maybe I am getting the temperature from some other source, that how much I have to, how much my furnace is having the temperature, something like that. So overall operating structure is this, and you think that there are few states, and I want to state this something like that. All right. So if even state there is A, means temperature is cold, so what should I do? I should heat up my switch on my heater. Yes. If it is into B, again I have to, here I think I have to switch on with the more temperature, and here I should maybe set the temperature to be a little bit lower so that it is into the operating one. In the D, if I get C, means what? Temperature is in this particular range. So what I have to do similarly, I think in all the stages I have to do some actions. Yes. So let me also say a simple thing to you. Let me say that there are three actions possible. What are these three actions possible? No work, nothing to do.
Increase the temperature, decrease the temperature.
Nothing to do. Nothing. Sorry, I think I'm writing up. So actions could be nothing to do, or it could be heat, or it should be cool. Let's assume there are three operations I can do. So if the temperature is high, I can say that I can apply the action cool. If the temperature is low, I can say that increase it, something like that. Let's assume that these three things I have in my hand so that I can switch on something. And these three actions I can do. Okay. So let me also say that action number 1, 2, 3. Action number 1, 2, 3. So I think now it is easy for me to tell you that here what I have to do. So in this, I think I have to heat. So I should take the 2 action because state is cold. So I have to, in every way, I have to heat it. If state is E2, whatever percept is there, I have to 2. If state is 3, then I have to take the action 1. If state is 4, then I have to take action what? I think 3. Am I making sense? Everybody is okay with that?
Yeah.
Yeah. This is how I have to do. Okay. So what is the size of this particular table? In this example, what is the size of this particular table? Size means number of rows. Number of rows. For this example only.
I think it's a multiplication, sir.
Yeah, how many rows would be there?
I think 4 into the number of percepts that we have.
4 into number of
4 into 4,
percepts.
probably 16.
5.
I think 5.
5.
20. Okay.
20 number of rows. Okay. All right. And let's assume that I'm going to make a agent. So who is going to stop me to write 1, 2, 0, 1, 2, 3, 0, not 0 is going to 1, 2, 3, 1, 1, 1, 0, 1, 2, 1. So if I create a vector of size 20, try to understand this thing. if I create a vector of size 20, where content is randomly coming from 1, not 0, 1, 2, and 3, if they are coming from 1, 2, and 3, if I come up with a vector and I say that this value is going to be here, this value is going to be here, this value is going to be here, something like that, this value is going to be here. So will this be an agent or not? Because from the agent, what we expect that it will be taking an action.
Yes, yes.
Will this would be able to take the action or not? So I can randomly fill all these values and I can make a agent, but talk in terms of how good it is. But it could be disastrous also. But I can make the agents. So how many agents are possible? How many agents are possible? The number of vector that I can create. How many vectors I can create? The number of vectors that I can create. For every vector, I have a function. Am I right or not? For every such vector, if I create any 20-dimensional vector, if I create, so this is going to be this. I can just map into my table, and then my agent is up. So every 20-dimensional, every time 20-dimensional array is going to be it can be represented as a agent. How many such agents are possible? How many such agents are possible? Please help me.
Sir, but in this case, you are covering multiple environments also, and you get multiple percepts also. So in this case, it's only one. Could not think anything more than that.
Okay, I understand. So how many possible, I'm asking, how many possible agents are there? Okay, definitely you would be only having one such vector to be represented as a function. So can I remove all these things on the board? Can I remove it? There's no
Yes,
problem
sir.
in this.
Yeah.
Yes, sir.
So now let me just, because it all become mess. Okay, so let me just give you simple thing so that it becomes easy for us. So we're clear. Let's do everything. All right. So what we had, let me just write once again that how many states? 5 states. E1, E5, 5 states. Okay. How many percepts? I think 5 percepts were there. No? 4 states. Percepts A, B, C, D, E. 5 percepts. States, 4 states. In the previous example, we had 4 states and 5 percepts. Okay. I wanted to make a function. I wanted to make a function that in this even state, if the percept is A, even state if the percept is B, even state if the percept is C, even state if the percept is D, E. So what I have to do? I have to tell that what I have to do. So what is the action that I'm going to take? So action could be even. What action I can take? What action I can take? I can take the action over here. So I think what were the
I think
actions?
heating, cooling, nothing.
Three actions. So 3 actions I had. So what we have said that this has 20 number of rows. So let me say that this particular place is actually attached to this particular cell. This particular place is attached to this particular cell. And by this, I'm going to create a vector of size 20 because 20 things were there, to 20 vectors, 20 size vector I'm going to create. What each cell is going to contain? Each cell is going to contain either 1, 2, or 3. These were the 3 actions that I'm going to take. This is our setting. So what I wanted to tell that if I come up with any of the value, for example, 1, 1, 2, 2, 3, any of the value, 3, 1, 2. So this value can be directly placed in this particular table. And now I get one table. Yes or no? Means I have all the values. Yes. If I have all the values, then any agent can take this particular table and perform the right actions, which are actually perform the action based on this particular table. So actions are possible. It is possible to take the actions. They can be disastrous. I'm not right now considering that particular way. So right now, this is how we make the functions. Agent function. Does it make sense? So this is how we can make a function. This is not a right function. Definitely, we are going to talk about that, how to make the right function at the end. So your question was that in the different environment, how can we operate with this? Yes, this was your question. If we have different kind of environments, how can we operate with the same thing? So right now I'm telling that let's assume that in the all different scenario, my agent is not changing. What do I mean by agent is not changing? That this table is not changing. The table is not changing, and I use this table. Can I perform in all the scenarios? I can perform something? Yes or no? If I have this table, then because system would not be beyond this particular states, you would not get any different kind of percepts. So in all the states, for all the percept, it is going to take some actions. So my agent is going to work. Yes or no?
Yes, sir.
Oh, yes, yes, sir.
Yes, sir.
Yes, sir.
So this agent is going to work. So this particular table has a special name called agent function. This table has a special name called agent functions. So when this this function, you have created this particular function, then after that you would be implementing into the program. And when you write the program, it is called the agent program. Nothing more than this. That when it is implemented in terms of the logic, it is called the agent program. Okay, so again, the question was, let me come back to my previous, our earlier question, that how many agents I can create?
The 3 to the power 20, right?
Correct. Excellent. So since I have a 20 size vector where I have to fill the values. Everybody is okay with that? I have 20 size vector where I have to put the value. At every place I can put 3 values, and they are independent to each other right now, the way we are actually talking about. So at this place I can put 3 values, at this place I can 3 values. So in all at the 2 places it becomes 3 multiplied by 3 values, possible values. Again, if this comes, so 3 multiplied by 3 multiplied by 3. So in essence, it is 3 to the power 20. So number of agent is 3 to the power 20. Try to understand how it is. So the below part is how many actions I can take. The below part is how many actions, 3 actions. And this is state multiplied by percept. These many number of functions are there. Everybody happy? Yes?
Yes.
Yeah, yes, sir. Got it.
No questions. Okay.
Can you repeat it once, please, sir?
What part?
The last part, the number of agents, how to calculate it?
How many number of agents? No? So essentially, I just want to give you the brief idea that for every state, because what is going to happen that from one state you are going to go to the another state dot dot dot, and at the end you are going to reach to some final state. So for every state, you have to tell that what is going to happen for every state. You have to tell. So what are the all possible states that will be there? So you know that environment can be right now, whatever we have said. Let's assume that the environment can have the state E1, E2, E3, E4. If environment can have 4 states, so in all the states I have to tell that what action I have to take. So what are the possible percept? Let's assume the percept are A, B, C, D, and E. 5 percepts are there. So 5 percept can be here in the first one. 5 percept can be here. For all the states I have to tell. So how many states we have? How many states we have? 20. This is clear?
Yeah, this is clear.
In every row, I can put 3 values over here, because as we have talked earlier, that if whether it is going to make the heat or cool or no action is also an action. So 3 actions are possible. So for every place I can put the 3 values. So overall number of things which are possible over here. So it is just another way of seeing on this, that if I take a 20-bit vector, 20 size array, so how many ways I can fill this? If the values could be 0, 1, and 2, 3 values are possible, then how many ways I can fill? 3 to the power 20. I think it is clear. Yeah. Have I answered your question?
So, are we saying that a single agent cannot do all these actions? We need to have these many.
So single action, how can it be done? So one action I would choose, and he would then perform the one action. Out of these 3 to the power 20, whatever I have put into the table, he would perform based on that only.
Basically, you are deriving at a combination set, is it, sir?
Yes. So all the possible combinations which are actually possible, I'm telling that these are the all possible combinations. But agent would not do all these combinations. He would perform only one way. That in this particular scenario, if this is the percent, I'm going to take this action. So how possibilities of developing this function is enormous, but I would definitely give him one profile only. So my agent would be working on the one profile only. Yes.
Okay, so there are 3 to the power 20 possible ways to develop this. That's what you're trying to say.
Yeah, there are 3 to the power different ways, 20 different ways of developing these functions. These functions are very, very much, but you know that many of them could be absurd, because the possibility is 1 1 1 1. Every time keep increasing the temperature. 0 0 0 0 means every time you just keep decreasing the temperature. All these possibilities are there. So many of them are going to be absurd. Let's assume that these are all the functions. Many of these agent functions are actually absurd. Am I right? And there would be one which looks like that. Oh, this is the kind of action I wanted. Yes, because right action, right way of doing thing would also be there, na? Not making sense. Not able to communicate. You? Everybody is okay that there are 3 to the power 20 different functions.
Yeah, I think you meant to say. I think you meant to say,
Yes, sir.
though there are 3 power 20 combinations, not all the combinations will be able to take any action, right? At any point, depends on the how the system behaves.
Once again,
only
number
one action can be.
Number 1 point. Out of them, to my agent, I'm going to assign only one profile. Okay, I'm going to assign only one profile. Let's assume that if I say that this profile I'm going to assign my agent, so my agent is going to work based on this only, and these things are not going to work. Okay, number 1. I have neglected all of them. I have only chosen one of them. Number 1 thing. Is it clear? Second thing, out of these possible profiles, few profiles are very bad. That we also understand. So we should not take them. Okay. My task is to find out the profile which actually does the things into the intelligent way. My task, how to do that, we will discuss later. But my task is to find out that particular profile, maybe this one, which actually, if I place this into my agent, then my agent would be behaving into the right way. Profile means agent function right now. I'm referring to the agent function. Does it make sense that I wanted to find out which one is the best one so that I can give it to my agent, and my agent works as a intelligent agent.
Yes, sir. Agent behaves well, as you said in the previous point,
Yeah.
based on the rationality.
Yeah, which is that one? We have to find out. How to find
Yeah.
out this? Again, I'm not answering that particular part. I would answer later.
But the behavior that we would recommend will be per percept, right?
Per percept. Yeah.
And
Per
the environment
percept,
also.
per environment. Per environment state. Per environment state. Per environment state. Environment, when you perform some action, environment changes. So in this environment state, based on this percept, what I have to do, it is specified into the agent function. Right? Correct? Any questions? Yeah.
No, sir. It's clear.
Yeah, great. So so what I wanted to tell, I want to bring your focus to this particular guy. Okay, this is a profile that is actually intelligent profile. I have to find out that. How to find out that is again a question that we are right now not accessing, but we will be going to this particular question and we'll be answering this in more detail. And this is actually important thing. We have also understood that some of them are very bogus, some of them could be average, and this particular one is the best. Try to understand that best is just a notion. It may be possible that this is also equivalently correct. It is possible, no problem with that. That when I say that best, maybe maximal, I wanted to mean to say this would also be maybe good. Okay, so if I want to find out anything, something like maximum, definitely I have a question that maximum on some value. How can I get that particular value? So there would be some evaluation. Okay, there would be some evaluation of this particular function agent, that how good this particular thing is. So there must be some evaluation function that can tell that evaluation function of the goodness of a agent function. How good this particular agent function is. Maybe this agent function is goodness is 5 and its goodness is 200. Its goodness is 110. Its goodness is 50. This goodness is 90. So I have its goodness is also 200. Okay. We have to find out what is the goodness. So there should be a measure by which we can tell that how good this particular thing, so that I can tell that okay, I'm going to choose this particular thing. So I have partially answered this particular question, that how to find out the good or best agent function. So what is the answer? Answer is this: devise a method by which you can evaluate the goodness, and then you can find out which is the maximum one, and you can go ahead with that. Is it making sense? Correct?
Yeah, sir.
Do you have any problem? No questions? No questions?
No questions, sir.
Correct. Now I wanted to tell you that you must have heard a story when you were a kid, that there was a cat who was eating all the mouse. So mouse has a meeting, and they decided that we should tie a bell to the cat. Understand? So the problem was that who is going to tide that particular value? Hmm? This was the problem. Have you heard about this thing? I have given a solution of that kind only. Because what I had told you, that find out a evaluation function, that I'm not telling you how to find out that. So again, going to be very difficult. Okay. And then I'm telling that evaluate for all of them. Evaluate for all of them. How many are they? 3 to the power 20. 3 to the power 20 is not a very small number. 3 to the power 20 is going to be very big number. Can anybody tell me quickly that how many bits, how many numbers would be there? I think I can square it. I can tell that it is going to be 3 to the power. If I take the 2 inside, it becomes 9 to the power 10. 9 to the power 10 means 9. Roughly, I can take 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this number? In 1 second, if I perform 1000 operations, that is actually really difficult. Then these many number of seconds would be required. These many number of seconds, can anybody tell me just quickly? Can you do the computation and can tell me that how many days is required? Just do it. These many number of seconds you have to divide by 60 to make it minute. Then divide by 60, divide by 24, divide by 364. What is this? How many number of days it is going to come? Can anybody help?
They're approximately
Sir, 11 days, sir.
116 days.
11
How many?
digits.
11 days.
11 digits?
11 days, sir.
11
DAYS.
days. 11 days. And just look about this particular problem where environment has only 4 states, percepts are only 5. Okay, and you can only take 3 action. How pity this particular problem setting is. But if you even if you have a system that have 1000 operations, 1000 evaluation operation per second, that is actually not possible because I have not told you how to evaluate that particular thing. It may take huge time. 11 days are required. Means I have given you the solution that is actually worthless. And that's why we are studying this particular course, that how to make it effective. Otherwise, this course does not have any meaning. Anybody can tell that, sir, I can find out the solution in this particular way. But again, the challenge is that the space is very large and it actually explodes exponentially. And that's why it is very difficult to find out that particular thing. The best one, that which particular thing I'm going to assign to my to my agent, determining that one actually is a big challenge. Any questions on that?
No,
Do you
sir.
agree with me?
Yeah.
Excellent. So now let me give you another example. So quickly, very quickly, we would come back. We have actually, I have not talked about one thing. Very quickly, we would come back to this particular thing, that vision, how to get the goodness, how to get the goodness of a agent function. This is a question that actually we have to answer, and then instead of brute force way, we have to do something so that we can effectively track this particular way, maybe in the log time or something, so that we can effectively very easily find out that what is the best one. So I'm just giving the high level. Let me give you a real example again, once again. So here I have a vacuum cleaner agent. Why vacuum cleaner agent? Okay, so here what this agent does, that it has 2 rooms, room number A and room number B. You have 2 rooms, room number A and room number B. So he can this particular agent has the capacity to go into the left side and right side. So so it can go left and go right, and it can also do one more operation, that is suck. And I can say that no operation. These 4 operations it can perform. Who can perform? This vacuum cleaner. It is an intelligent vacuum cleaner. So if there is some dirt, so it can apply a operation called suck. So if he applies the operation suck, let us assume that this particular dirt would be would disappear. So everything would be clean from here. If he applies the operation called suck, then let's assume that right now that it would be cleaned over there. If you take the go left, okay. If you take the operation as a go left, so left there is nothing, so he would be into the same room. But if you take the go right, he would be moving into this particular room. Again, he take the right, then he would be into the same room. So in this way, go left and go right are going to work. By this, it can change the rooms, and it can go and suck to the particular thing. And what are the percept? So let's assume that the percepts are this, that location. What is my location? Location gives you A or B, that whether you are into the room A or B. GPS, let's assume here is GPS. And second percept is that dirt is there or not. If D, he can also sense. Let's assume that there is a sensor that it can do vertical sense or not. Okay. Any problem in this setting? So I am going to write a agent program for this. Okay. I'm going to write a agent program for this. So how can I write an agent program? I can say that if D is equal to yes, so let's assume that D can have value yes or no. So yes means what? If D is equal to yes, because there is a dirt in the room where the agent is there, it has a dirt, then suck is not room, means change the room. Is it a good vacuum cleaner?
Yeah, move to the other square.
Say again.
Move to the other square, sir.
Yeah. Other square room, whatever it is. So how can I write move to other room? Again, I can write now if LOC is equal to A, go right. Is means room would be B only. Then go left. Am I right?
Yes, sir.
Have I written the good code? Okay. So by applying this code, can my vacuum cleaner operator operate in a full way? Yes or no? So what my operator would do? So right now this is working in this way. If the current sequence is dirty is yes, then suck. Otherwise, move to other room. Okay, this is what I have implemented. Okay, so is it an intelligent agent? The first question that I wanted to ask: will it work?
Yes.
Answer is yes. Okay, everybody knows
Yeah.
that it is.
Yes.
There will be no exit condition.
Say again, sorry.
Not
There
cover
are
all
no
the
exit conditions. Like at what time this should be stopped.
No op is not actually given. Huh? Okay, right now I have not written, so I'm not telling that my code is correct. That is a problem. That's fine. Okay, so what makes this agent intelligent? Okay. So the problem is this, that you know that if there is no dirt, this is actually moving one room to another every time, and actually he's not taking any rest. So I call you that try to suggest something by yourself so that it could be a better one. Can you suggest something? This is fine in terms of the doing work. This is fine in terms of the doing work because the room would it is every time it is doing. But what is the issue?
Sir, but how
Uh,
to how to find whether the room is already covered or not?
So if continuously it is not able to detect any dirt while moving into the along the boxes, we can do an auto off.
I think for this you can use the history.
We can keep track of the which room is cleaned before and just do the other part.
Yeah, this essentially means you are going to keep track of history.
Correct.
Right? So
Yeah,
maybe by incorporating the history, you can make it better. Yeah? Instead, right now it is only taking the decision based on what is inside this current room, but you all are suggesting that instead of this, you should also see that what has been happened earlier, and then this would be more intelligent. Okay.
correct.
So right now we are into this particular scenario where we actually are going to see that if I am inside the room A, room is clean, then go right. If I am into room A, room is dirty, then I'm going to take this sub. If room B and it is clean, then going to the left. B and it is dirty, then I'm going to take the sub. So the program, which actually just we have seen, the agent function could be this. Am I right? This is the agent function. Okay. So this is the agent function that actually we actually talk about there. But we have seen that this agent function has some issues. So what we can do, we can incorporate some of the memory also. So this, let's assume that 2 memory I have taken. So again, but how many memory I have to take? We have to see about that. So based on that, actually this size actually increases, and we have seen that this actually, when we increase more number of things into this, so the number of action, the possibilities of number of agent function is going to be that action raised to the power history size multiplied by percept states. Percept states means here how many states are there. So this we have already seen that becomes a very big number and becomes a challenge to find out which is the right row. So I think this part is clear to you. So again, I think very easily you have understood that by incorporating the history is going to help us. We have talked about that we are actually interested in developing the rational agent only, and one which does the right thing, and sequence of action of agent leads to the sequence of states of the environment, and there should be a performance measure, and based on that performance measure we can pick which is going to be better. So right now I'm going to tell a very important thing, and please focus and ask me that if there is any confusion in this. Okay, what I told you, that possible number of agent function is very large. Possible number of agent function is very large, and we have to pick the one function which is actually good function. How to find out that function? It would be depending upon the performance measure. I have to define a performance measure. So let's assume, let me give you a problem. Let's assume that there is a autonomous driverless car. So what could be the performance measure? Can you tell me?
No accident.
The less number of accidents it's make.
Less number of accident.
Shortest path.
And how fast it is able to reach the destination.
Shortest path. Time taken.
How well it is
Lane
able
discipline.
to keep its lane.
Lane discipline.
Legal, you want to say that how legal he is driving?
Yeah, rules, traffic rules.
How many
Traffic
rules it
rules.
is? How many rules it is following? Okay.
Distance it is maintaining from the vehicle which is in front.
This is again a legal one. Anything else?
Dodging obstacles.
Dodging obstacle. So otherwise you will not be able to drive now. Let's assume the driving is happening.
Sir, if the
So-
petrol or gas is empty, what action you can take?
Petrol is not there, huh?
Petrol or gas is less. What
Mhm.
actions it should take? It should take.
I think it should be electrical.
Acha, you want to maximize, minimize the minimize the cost.
Failure rate.
Minimize cost.
Able to
Okay.
identify false positives.
Maximize profit. Profit means because autonomous car, there is a company now who is running this. He want to maximize his profit also.
Handling breakdowns. If there is a
Handling
breakdown,
No, breakdown, how car can handle?
it can give some kind of an alert beforehand.
Okay, so is it a performance measure? I'm developing a car. I want to develop a car such that it should behave good. So what should be the goodness? A good car maintains. Opening us means?
Opening of airbags in case of accident, safety measures.
Safety.
Mileage can also be one.
Mileage means minimize the cost. Minimize the cost. Okay.
Sir, maybe scheduling its own maintenances.
Scheduling maintenances. So is it performance means? How performance? When everything is okay, then you go to that thing. Okay. Let us talk one by one. Okay. Maximize profit, it could be one thing. Okay, because it's a company, they wanted to get one good thing. Okay. Time taken, I think this is a very interesting thing to tell, that because somebody is traveling not for the traveling, you want to reach somewhere, so you have to minimize the time. That's very important. Okay. Lane discipline is again very important thing that we have to do. So how goodness can be measured based on the how good he is driving, because rush driving, doing accidents, again number of accidents should be minimized. Shortest path, where he is covering the things into the shortest path or not. Okay. So these could be these could be the performance measure based on that. Okay. However, I wanted to tell you a very interesting thing, that these performance measures are sometimes contradictory. And you may have experienced it, that in the Delhi, if you are at the place A and you want to go to the place B, so the taxi driver would forget about Delhi. Okay. If he want to maximize the profit, he want to go from this particular way to here. Am I right or not? Taxi driver would not like to go into this way. From here to here, he would not like to go, because then he would only take the 20 rupees. But if he go in this way, he can charge 100 rupees. Yes?
Yes, sir.
So if the performance measure is maximize profit, is it a good performance measure? In terms of his operation, this is a bad performance measure. If I say that if I say that minimize gas, for example, thing. Okay. So it may be possible from A to B, there is a long route. Okay. So this I have experienced when I went to BITS Pilani Hyderabad campus. So from airport to BITS Pilani campus, there is a long route. Okay, so this airport, the city is Hyderabad city is like this, and outside there is a circular road. So you go from here to here, it would be faster. But if you go from here to here, it would be the shortest distance. It will be the shortest distance. So what would happen that if you want to minimize the time, you have to go from this particular way. If you want to minimize the distance, you have to go by this. But if you go by this way, if you go by this way, your time is going to be increased. Okay. So if you go by this thing, if your time is because distance is lower, so it can minimize cost. So do you want to minimize cost or do you minimize the time, which is more important for you? Most of the time is most important. Okay. Try to understand in all the things, time is most important thing. Why? Because time you cannot purchase. You can purchase everything. Even if the gas is very costly, but you can purchase it. But you cannot purchase the time. So if you say that minimize the cost, this is a wrong method to develop the system. This should not be the performance measure. Performance measure should be minimize the time only, not the cost. Lane discipline is again very important thing. That lane discipline somebody should follow. But only following lane disciplines and going from this particular side is again going to be a big problem. Yes or no? Less number of accidents. Again, I think it comes into this lane discipline only. If somebody is following the lane discipline, and then definitely there will be not action. So we can combine these two things in one. So we have understood that what is the importance of the shortest path, shortest time, maximize profit, and minimize cost. This fourth thing I wanted to cover. And I wanted to tell that shortest path is a good thing. Time taken is good thing, but maximizing profit is not a good thing to measure. Yes or no? In the same way, minimizing cost may not be a good measure. Am I right or not?
Correct.
A system is very good because if I put this one, if I'm maximizing cost, if I put this as a performance measure, it will be very good for the company. But for the overall society, it is not going to be good. So this is an important thing that I wanted to tell you today, that performance measure should be evaluated how the environment is desirable, not how the agent is desirable. Company is making this particular autonomous vehicle because he want to maximize the profit, but the performance measure should be based on how good it is going to be inside the environment, how good it is going to be on the roads, not based on the profit. Does it make sense? I would just give you a last example. We are at the time and close this session. So I wanted to give you another example that is very catastrophic to have it. So let's assume that you want to be successful in your life. Okay? You want to be successful in your life. So successful. You all are agents. You want to be successful in your life. What should be the performance measure? What is your bank balance? Whether you have a house, whether you have a car. Okay. How many vacations you have actually done. This is what the success measure we have. But if I put this success measure and plan anybody that you have to get all these things, what he should do, immediately I can get the money because there is a bank. I can go inside, I can just purchase a gun and go inside the bank. I can tell, give me 50,000, give me 50 lakh rupees. So I can take the money from there. I want a house. Go. A lot of houses are there. Go in any house and tell the people that, hey, please vacate this house because I want to live over here. Within 1 hour, you will be able to get the house if you have muscle power. Okay. Car, lot of car showrooms are there. You go inside any car room and just take the car and take it away. Who is going to stop me? I'm going to take, because this is the measure of success. So if measure of success is this, the system is going to be disrupted. Our society would get disrupted. So this should not be the success of measure. What should be the success of measure? I think you
Oh,
should.
happy with.
Yeah, how the environment is good. So if you are inside the environment, your environment should be good. How you are making your environment good, then we know that okay, this is not the right way to earn money. Right way is earn money to provide some kind of services, get the money based on that, and then you would be going into the right way. Okay, so measure should not be this. Measure should not be something else. That how well you are making your society good. I think with this, I would stop and put more light on this in the next sessions. Thank you very much for being with me. Any more questions? I would love to answer your questions.